Recording now. Give me a slide transition or something, or move the slides back up. Anything obvious I can sync with?
Right. Those?
That's pretty good. That's really good. Yeah. It's on you. You're awfully dark, but we're good.
All right.
I'll move it.
We good? All right, everyone. This presentation is titled Data Hiding in Your Application. So, first off, who am I? I really need to get the whole technical difficulty thing kind of threw me off. I'm Joshua Bartley, I go by Josh. Currently senior applications developer for Harlan Payment Systems. I have 10 plus years of development experience. I'm actually like full-time developer. I'm not a security professional by trade. I lean on wherever my security guy just went over there for security issues. Started joining some sketchy IRC channels by the age of 14. That's kind of where the bio thing came in with the AOL and my dad. That is true. That actually happened. That was an awkward conversation. I wrote one open source program called SmallNav. I'm an A+ and Net+, and I failed by 6 points for the CCNA. And that's my Twitter handle if anyone ever wants to get a hold of me. I gave up on the CCNA after that. I was like, I'll just be a developer. Who's this talk for? Developers who mainly write enterprise applications. Some of the talks already kind of just reinforce what this talk is talking about, because the keynote talked about 40% of breaches are internal by employees. If you're writing an enterprise application, this is probably targeted really towards you even more. Also, some focus on web servers. If your web server gets compromised, you're kind of hosed anyway. But part of this talk is to kind of letting you know how hosed you're going to be. You know, are your AD credentials that were sent over SSL, but they're plain text in memory, and your domain admin just logged in? You're hosed. Your entire company's out at that point. Some untested implications on mobile devices. The Nexium talk just talked about some of those issues as well, where, you know, what's in memory, what do applications have access to, what's in the sandbox, and what data is being shared between the applications. So, when did this really become a big problem? Well, in C#, I'm a C# developer. I'm going to go ahead and say that. I'm not Objective-C or anything like that. The CRL does something called string interning. Basically, it's a cheat and a performance trick to make C# a managed language as fast as C++, an unmanaged language. So it maintains a table called intern pool, which has a single reference to every string. So if you type in the string test 20 times in 20 different text boxes, that's actually only in memory once. But the fun part is, it's immutable. So what happens is, when you type in test and you delete it from that text box, it stays in memory in that managed framework for a while. You have no clue of when it will be removed. You're not told when it will be removed. And you're not allowed to remove it yourself. So, quick little diagram I stole of what this really is. You've got basically 4 pointers, and they all point to the same text string on the heap. If you make any modifications to hello, you get hello 2, and then hello 3, and hello 4. Those all stay in memory. I actually have a live demo showing that while you type what happens. So, it's not just a .NET thing. String interning is supported by some modern languages: Java, Lisp, Scheme, Smalltalk. Objective-C has some for selectors and method names. Lua also has some string values that are immutable and interned. So, not just a .NET thing, but since I'm a .NET developer, I'm trying to focus on that. Also, I apologize if anyone has motion sickness from my presentation here. I don't like PowerPoint, so I refuse to use PowerPoint. So, garbage collection. It's kind of the foundation of managed language. I will control your pointers for you, so you don't get the unreferenced pointer error and the entire operating system crashes on you. But because of that, it's all hidden. What happens to your data in your application is hidden away from you. You don't know when this will get cleaned up. You just know it should get cleaned up, and you know how you can help get it cleaned up when it happens. But you're not given, after 5 method calls, this will be removed. It says it will happen at some point. So, kind of quick little example, username and password, here's it just kind of sitting in memory. We're going to go into some more about this, but I also love this URL right here, if you can read it, from Code Project, Why Hackers Love String Data Type. I think kind of just helps the presentation.
Question about the last statement. Does that exclude direct calls to like a garbage, like a collect method from?
If you do a collect, the problem is strings live on the large object heap, which is not part of generation 0, 1, or 2. So it's only really cleaned up when there's a lot of memory pressure. But you can't directly say, I want you to clean up all my strings. It will say, I'm going to try to clean up some object references, but I'm going to leave your strings alone.
Okay, so calling into the namespace directly even with the .collect is not that.
Yeah, I actually tried that 3 days ago. I was like, oh, this should work. And I was like, oh, it doesn't work. I have a code sample that will explain a lot, too.
Can you flood it with junk?
I have a code sample that will explain some of that. It's a little bit further ahead. Okay, so where does this apply? Kind of some scenarios to think about. Do you have a database that contains a bunch of your secrets? So do you have basically one connection string to some database store that you centrally manage all your information for your company? Do you have a single sign-on portal? You know, is that just a web-based single sign-on portal that people type in their username and passwords and you handle on the back end? And those passwords happen to stay in memory. Do you have a connection string with a SQL account, you know, floating in memory? You know, not using Windows. Using Windows authentication lets you remove the password from the equation in the .NET world. But if you just have the SA account with some password in the connection string, that's going to be in memory too. Here's another one. What if your application crashed in production? You have a dump file. Do you just hand that off to the developer? Well, that contains all your production secrets, connection strings, everything. Actually, that happened at a former job of mine. I had to write a program that ripped all the secret out. So, great point is, how do you fix that? One, don't do it. If it's a secret, it's a secret. Store it that way. Don't trust client computers. You know, from the keynote talk, 40% of breaches are from internal employees. Those internal employees are running on client computers in the enterprise. Use the secure string class. This is where the code sample comes in. Verify, verify, verify. That's what I had to do to make sure what I was doing didn't leak out the strings. Aaron, one of my coworkers, I was actually showing him the demo for this earlier this week, and I showed him the demo, and I was like, oh, it's in there twice, never mind. He's like, yeah, you've got some work on that still. So, samples. Example using secure string. So, simple console app in C#. But again, this is also, secure string is a Windows API backend call.
Just slower.
Security is always kind of slower.
Well, wasn't that the point of the other string class, to make it faster?
String Builder makes it faster, which manages things as a character array, not as a set of strings in the string intern pool. So, it's very close, but it's a little bit different. If you have a character array in memory in .NET, that's stored in generation 0, 1, or 2, not on the large object heap unless it gets really big. And you're allowed to clear that out. The managed framework can still move and copy your memory around. So even though it's in a character array you cleared out, there could be 3 other copies of that character array in memory. I also have a code sample to tell you how to fix that.
I'm sorry, this secure string class?
Yes.
That's coming out of the system security namespace?
Yes.
As of which framework?
.NET 2.
2, thank you.
Yeah. The kernel APIs, though, are available if you want to call it yourself. So you can also do this in a C++ app or any other app that has access to the kernel APIs. So basically what this is showing is the secure string framework is designed to where you can't give it a full string by itself. That's by design, so you don't have that in memory. You have it character by character by character in memory. So if your secret is in memory, but it's spread across, everything character by character, it's a lot harder to find it out than it just being right there in plain text. So this is just a sample using the console. And then you can see here, process.start actually accepts the secure password for the user for that domain account if you run into that situation. Also, at the end of this, there'll be a link to this entire presentation so you can nab these code samples. So where can you apply this? Windows Forms app, encrypt while the user is typing. You shouldn't send the secret plain text over the wire, so you're really not going to have to worry about WCF in that case. Use hashes if you do have to send it over the wire. If a hash won't work, you're going to have to do it byte by byte. I don't have a sample for that, but that basically prevents all the internal buffers for WCF, for SQL Server, for all that, not to basically live in the same spot. So you basically don't have the string sitting in memory even though you thought you got rid of it. That was the problem I had when I showed my coworker that demo. And no one ever said a secure application was fast, but you can cache the secret because once it's in your process, you can manipulate that secure string as much as you want. Yeah.
Doesn't the user, once the machine is compromised and they can reach your memory, can't they in a way see your stack and see reverse engineer to get to the end secret password?
The secure string stores memory in kernel space outside of your process. Yes, if someone were to compromise your machine, they would have to go through additional steps. They would first have to hunt up the encryption for your process, but it also prevents issues of when your process is dumped to disk or when your process is dumped to the page file. It's dumped in an encrypted fashion that once you reboot or anything, it's gone. This isn't like you encrypted it and it's always gone. At some point, you're going to have the key. But this is just trying to shrink, basically, the attack vector. Windows has some security built in, like if you're not an administrator, you can't access another process, so that means you can't get at this data kind of thing, too. So, did I answer everything? Okay. Okay, so what if you really need it in plain text for some reason? There's a way to do that. So you basically, first you always do good coding practices. Second, you call this marshalling call to basically get the secure string to a global Unicode variable. Then you return the pointer to that string. So this is saying, here's a string, it's outside of the managed framework's memory space. Here's a pointer to it. .NET won't basically intern that for you. So when you're done with it, you can basically zero it out, it's gone. Also, .NET won't move around on you either.
Is the namespace considered unsafe at that point? I mean, with using the marshalling class, I mean, say, for instance, you're writing out a SQL CLR or something like that. I mean,
Good point.
Does that change it from completely managed to like half in, half out?
Well, if you're writing a SQL CLR, hopefully no one has access to the memory of that database anyway, because if they did, everything in your table is unencrypted as well. Even if it's stored on disk encrypted, I think. It's unencrypted in memory. So you would have bigger problems to get access to your database. And you're not allowed to pass a secure string, like you can't serialize it over the wire. It's per the process. So once it leaves that memory leaves that process, it's garbage. You can't get at it.
So it's with the access and the scope of whatever is declared.
Right. Close to it. Also, some links to where these code samples came from for some more information. Quick quiz. Will this have a plain text copy of the secret? So what this is doing is it's connecting to SQL. It's saying, I want this secret stored from my secret store of secret ID, whatever one it happens to be in this case. You're basically saying, give me the value of my secret, 1 byte at a time and adding it to the secure string. When this exits, what do you think happens? What do you think's in memory? Say again? Actually, the value of your secret is stored at least 2 times in memory from the SQL client. So this is when, in the previous slide, I said you have to send things byte by byte, or you can't really guarantee what's going to happen. That's what happens. You see it right there. This is a secret. By the way, that's Notepad++. You open up Task Manager, right-click, dump file, open up in Notepad++, you can see everything. So think about it from an enterprise user. Do they have access to Notepad? Yes. Do they have access to Task Manager? Well, Control-Delete, everyone has access to Task Manager, I think. So that's how easy it is to get that information. Kind of scary. This is why my security guy, I ruin his day all the time because I bring him scary programming situations like this. So I stole this from XKCD and kind of, changed the wording around a little bit, but we have a demo. So all right, so you get to see my awful quick coding here. I wrote a simple console application. It's basically going to say, give me a string that I will basically fake it to make you think it's secure. Then I want you to give me a string to encrypt, and then give me the password to encrypt it. You won't find that in memory anywhere. Then I'm going to basically decrypt it for you. Then it's going to show up in memory because, well, you decrypted it. It's in memory. So here's kind of some of, this is very low-level like developer stuff, probably even more than most .NET developers. So, garbage collection for the managed framework. When you have a value or a byte array, the framework can basically say, your byte array is in the wrong spot. I need you to move over here. To make it efficient, it leaves that old data in memory. So what you have to say is, hey, I need this amount of memory, and I need to basically pin it. You're not allowed to move it until I tell you you can move it. This is actually not recommended because it basically degrades performance. But for security, you gotta, basically outweigh that. So then I'm saying, all right, I need to take my secure string, and I need it basically to go to plain text. Then I want to copy that to this byte array up here that's pinned. Then I want to basically free up that string I just made and zero it out. So now there's basically only one copy up here of this string. We move too far down a little bit. You can see down here, because I have pinned the memory, it won't move. I'm allowed to basically wipe it out with zeros. This will work. So I will actually fire up the program. Okay, someone want to give me a string to type in so you know I didn't fake this? No, I don't. Easy. String? Come on, give me a number afterwards.
478.
478, there we go. Okay, looks good, right? Okay, give me a second string. Come on, people, be more creative. I just typed it in, string orange. Okay, and then I'm just going to use blah, blah for the password.
Now, before you type the rest of that, am I correct in assuming that if we were to dump it right now, we would see it?
No, let me show you. Well,
No,
which string are you talking about?
Before you press enter, we
Well,
would
no,
see
which string are you talking about?
the second one.
No, you can't see it.
Because you haven't wiped it yet.
No, because when the characters went in individually, I immediately shoved it into secure string. So you would see a list of characters in memory at random locations, not together. The first string you would see as a single string. Let me show you the memory real quick.
You declared it initially as a variant type, right?
Yeah, that's
and
just
and then it's implicitly converted, like you pull it out.
actually a variant type. The compiler determines what that should be at compile time. So it's just, I'm a lazy developer. I didn't want to type string, I want to type var. So, my cheat sheet over here. Alright, so here is what is in memory, and hopefully my program works as I tried it the last 20 times. Okay, so string 478, the string we typed in the first time, that was a right string, right? Because string orange was a encrypted one. Do you see, now, I have a bug in my debugger where I missed the first character. I apologize for that. I was fighting a Unicode bug before that, and I just was like, all right, this is good enough for the demo. So you see, we typed in basically S, which is supposedly would be right about there. We typed in SR, SRI, but we were typing it character by character. What was happening in this code, way at the bottom, where I was basically reading the key individually and then just appending it to the string. It's not how .NET works. What it did was it said, all right, it's a new string. I'm going to give you a new string. The old one, it's staying around. It's gone. You don't know where it is. You don't know how to get at it. You don't know how to clean it up. So then you see eventually string 478 came up, but out of all the strings, I cannot find orange. Now, if you make me search for O, of course something's going to happen. There's a lot of strings in .NET by default. You can just see all of them, including where this program's running from. And apparently I'm missing 2 letters on that one. So this is using the code sample I had before. This is where, for the secure string one, I was reading the key as a single key event, appending it immediately to the secure string as a character. So it's basically going straight in to that protected memory space, and then I basically made it read only at the bottom, but that's up to you. So it's protected. You can't do anything with it. And then once I detach the debugger, you can see that it encrypts it, and then it can decrypt it straight back again. And that was an encrypted string. Thankfully, it didn't show up. So, simple example, this is again console application. Let's say you had a Windows Form application in your enterprise that accepted credit card payments. Would you want, and I can't bring it up because it closed it, would you want that credit card in there 16 times, basically, once for each digit, and then it just incrementally gets bigger? For someone who's basically RAM scraping, which was 95 breaches in 2011, as reported by the Verizon data breach report, how easy would that information be for some attacker to get? How easy would it be for the employee of your enterprise to get at with basically little to no trace besides a single dump file, which, how many people have a dump file on their computer in the enterprise? Everybody. Things crash. So does that look suspicious? Does it not look suspicious? How do you prevent against that? So this is how you do it. Again, all these code samples will be available. If I can find my mouse. So if you would like this talk, you can scan the QR code, because I'm really curious about my scanned QR codes. And then here is the Google link. It is case sensitive. I gave one of these to a group of high schoolers. I have no clue what they got when they didn't realize it was case sensitive. So, questions? You look like you have a lot of questions still. Yes?
So, I'm trying to understand the real scope of the problem. With user isolations controlled by the OS, how big of a deal is it to prevent dumps from the process? Or is there really a way to stop dumps?
It's not just dumps, it's even swap file. So, can you prevent something swapping to disk? You can't really. So, you've got your dump files, you've got your swap file, and then you have user-initiated dumps. And then you have what I just did, which was just load up a program and attach to it, which leaves no physical trace on the box, because that's all running in memory too. So the scope of it is just trying to limit basically the sensitive data in memory and people getting access to that sensitive data really easy. If somebody's going to spend the time, energy, and effort to write a program to find the decryption keys from Windows to decrypt your secure string, they're really focused on you anyway. They're going to find a way in one way or another. So this is just basically trying to say, this door is closed, go to the next one. This isn't saying this is a steel door, you can't get into it because it's a bank vault. It's just saying go somewhere else to find a problem.
You talked about like a WinForms app, like credit cards, but I mean a dump there is really only going to be a representation of all the credit cards that say that person has collected or typed in.
Or the SA account of your database, depending on how you connect to your database.
So credentials and things like that that are operating within inside the context of the application.
Right. Because I don't know about your enterprise, but I've been in other situations where it's just a simple SA account that the application has access to. It's encrypted, either the web config is encrypted, or it's hard to get at, or it windows off to a store to get the information. And then once you have that, you have read, write, and delete on every table in the database, bypassing all the security your application provides. I'm not saying that's the best case scenario, but I'm saying if you do that, you might want to look at secure string to, start limiting those attack vectors.
Does that work with
Good question. I didn't look into that. It's dependent on a Windows API call. Linux, if it has a similar API method, Mono could have done it, but right now I'm just making stuff up, so I'm hoping Mono has something similar. Yes?
Is there a difference between with this or the web form or web form?
A web form, the data is going to sit on the web server, and then the problem you have is you can't, right now, and I couldn't find anything, where you would, if you typed into a web form, send it to the server, once the server got it and went into memory, it's immediately in that string intern pool. It's just like the case with the SQL connection I showed, where you thought you were getting it byte by byte, but really it was already in memory. Same scenario. So you would either have to pass it, character by character to the web server, or do something first to pass it up. Like if it was a password, hash it before you send it to the web server. Because if someone compromises that web server, or even you have a malicious employee, they could pull your domain admin's user if they log into that account or that web form. Or credit cards again. They type in the credit card numbers, but you can't hash those because you still have to process it. But you could do something to change it up a little bit. Questions for this side of the room? You all have been pretty quiet over there. Questions again?
The question is, if you're concerned about just a user visibly seeing it in plain text, could you just put it into X?
That would be pretty noticeable, and then that would be really easy to find as well. If you put it in, that's just basically, changing a number from base 10 to, base 1.
It makes it obscure, though.
It makes it obscure, but not secure. Right. So you've obscured it. It's really easy to get it back. This secures it up a little bit more than that. If you want to hex it and then throw it in a secure string, well, then you're just confusing people. Probably even the developer. The developer's like, I don't know what's going on here. You've got this hex string. I was expecting something else. What's up? It's like your user account is like 0x5a. They get confused. But yeah, you can change it up a little bit. If you obscure it, that's one way to do it. But this is the recommended way by Microsoft for sensitive data. Best way to protect sensitive data: don't put it on a computer. That someone has access to. Shove it in a vault, shut it off, and walk away.
Use token.
Yeah.
So what's the recommendation for strings like this, username, password to like WCF service from the client? Are you saying that's still byte by byte?
If you use it, if your secret is authentication or authorization, you can hash that. HMAC's a good option for that. If it's some secret you have to mess with, tokens or send it byte by byte to get into secure memory is a good way to do it too.
But that translation from what they're typing to what's being processed by the service is going to be done client side. Right?
Say that again.
What's going to convert, their password to what's going to be submitted to the web service for final authorization and approval is going to be client-side processing and programming.
Yes.
Some JavaScript or something. So maybe what's keep them from kind of dissecting that?
Well, they already have the secret in this case. So what you would do to secure it in transport so you can pull it out and then throw it back into a secure string is really just something that's temporary. If you create a temporary key for the user to encrypt it or hash it or whatever, and only applied it to that user for a 10-minute window, then what would they gain?
With like a disposable key.
Right. Or, you know, an RSA, not RSA, well, AES key or something like that, and they just dispose of it, and then they can't use it again for any reason. They can't go to the server and decrypt it because it was a one-time thing to throw it in a secure string and then throw it somewhere else. So, and then when you send it to SQL, you'd have to send it byte by byte, which would be slow, but, you know, I would assume you're not, basically your secret isn't a, you know, a DVD file, you know. That would be awful sending byte by byte. No one would want to do that. The amount of packets. So, does that answer everything? Okay. If you have any more questions for me, just hit me up. So, did you get that? The Twitter? No. Okay, it's Josh A. Bartley. Right there. So, preferred method of contact. I try to stay away from Facebook. And no one uses Google+. So, any other questions before he starts clapping me away? All right, well, if you have any other questions, you know, hit me up on Twitter. If anybody needs me to put up the Google link again, just let me know. And this is just proof that no one scans QR codes, so thank you for that.
Put it up, I want to try it.
Oh, you want to try
It's
it?
too far away. I'm going to have to come closer.
There you go.
Is that that jQuery mapping?
Thank you. Huh?
Is that jQuery mapping plugin?
No, this is actually Prezi. Yeah, it's an online presentation tool. I blame the millennials, my generation, for it.